How can you write tangent x in terms of sines and cosines? Sine x over cosine x. So this looks like a job for the quotient rule. We have a quotient of two expressions, each of whose derivatives. So here goes. It's gonna be. What do we do first with the quotient rule? How do we do this? Take the cosine x and square it. Yes, cosine x. If you want to go ahead and say cosine squared x, I'll write that at the next step. But take the cosine x, put in the denominator, square it, just like that. While we're thinking about cosine x, write it down again. And then multiply by the derivative of that other function that we're having to deal with in this example, the sine x. Put the minus. And since we just wrote the denominator times the derivative of the numerator, now we want to write the numerator times the derivative of the denominator. Just like that. Now let's recall what those derivatives actually were. Off here in the corner somewhere, we want to remind ourselves the derivative of sine x equals, anybody remember?
Cosine.
Well, it's one of those. It's actually just plain old cosine x if we go in this direction. And if we want to go back, that's where that negative sign comes into play. Derivative of cosine x is negative sine x. All right. So as we simplify this, we'll keep this in mind. So we get cosine x times negative cosine x minus sine x times, oh my goodness, wow, they pay me real money to teach this course too. Not a whole lot, but they do. Derivative of sine x, it's cosine x, I just got through saying that. Derivative of cosine x is negative sine x. Don't know where that came from. All over cosine squared x.
So the top's going to be 1?
Well, the top is going to be 1. It sure is. Look at that. Cosine squared x plus sine squared x over cosine squared x. And our familiar Pythagorean identity, that is 1 indeed, over cosine squared x. So we can write this in terms of secant. Secant squared x, cosine x and secant x are reciprocals of each other. So 1 over cosine squared x equals secant squared x. Mark it down. Probably a dozen or more times between now and the end of the course, you'll be called upon to take the derivative of tangent x. And you just want to have it memorized. Secant squared x, that's what it is. Derivative of tangent x is secant squared x. So all 6 of the trig functions, you want to have the derivatives memorized and make sure you can recall those. Now the derivative of cotangent x is similar. I'm not sure if I want to take the time to go through all that. Maybe just leave it as an exercise for you, but I will go ahead and say it's equal to negative. I would just say, someone have a guess what it might be.
It's going to be cos factor. Is it secant? You flipping it though. Oh, cosecant.
It's going to be that. Yeah, derivative of tangent x, secant squared x. Derivative of cotangent x is going to be, you would think maybe just cosecant squared x, but it turns out to be negative cosecant squared x. What happens, let's see, what happens down here is that in the numerator,
You think you just flip it because they're the opposites? It doesn't turn negative. Like you have the sine x and the negative sine x, it's going to be in different spots.
I feel like I should actually work this out.
Like sine squared.
We're going to end up with a negative sine squared x minus cosine squared x in the numerator, and we'll factor out the negative sign, and then we'll have negative 1 there. And in the denominator, it will be sine squared x. That's the way it shakes out. I don't know how obvious that is, though. So let me just go through it quickly. It'll be, if I write this as ddx of cosine x over sine x, it looks like this. You have the sine squared x in the denominator, and then it's sine x times derivative of cosine x minus cosine x times the derivative of sine x, and then it's sine x times negative sine x minus cosine x times cosine x over sine squared x. So there you go. Negative sine squared x minus cosine squared x over sine squared x. If you factor out the negative sign, you get 1 on the inside. So negative 1 over sine squared x, and that's negative cosecant squared x. It'll be kind of a recurring theme. We take the derivative of a particular function. The derivative of the cofunction will be similar, but will have a negative sign associated with it.